so now we are looking at the composition of trig functions with its trigonometric inverse function. It sounds trickier than it actually is. Let's go ahead for this first one. We're going to work this direction. So let's start by determining the tangent of pi over 6. And again, it says exact value, so I know that I'm not using a calculator. So pi over 6, that's 30 degrees. So earlier we talked about our special right triangles. If you aren't familiar with them, go back and watch the previous video. So our special right triangle has specific ratios here. So pi over 6, 30 degrees, opposite that is always 1. Opposite 60 or pi over 3 is always root 3, and opposite the 90 is 2. So the tangent of pi over 6, tangent is opposite over adjacent. So opposite over adjacent is 1 over the square root of 3. So now we're looking for the arctangent of 1 over square root of 3. Arctan is another way to write inverse tan of 1 over square root of 3. So don't let that confuse you. It's still just asking you to find the angle that has a tangent of 1 over the square root of 3. Well, I feel like we just did this, right? Opposite over adjacent. Look at that, it's pi over 6. So we have just come full circle. Okay. So if you are, just kind of a generalization here, so let's say we had arc cosine of pi over 6, that would also be equal to pi over 6, because these are the same trig functions. Okay, so on this next type, we're still going to work this direction. So we're going to look at the inverse cosine of 4/5. Again, that's saying find the angle that has a cosine equal to ratio equal to 4 over 5. This is not one of our special right triangles, but that's okay. We still have the Pythagorean theorem. So cosine is adjacent, the ratio of the adjacent side over the hypotenuse. We're going to use the Pythagorean theorem, and that's going to be 3, because it's a 3, 4, 5 triangle. It's one of our Pythagorean triplets. So let's identify which angle we're dealing with. So we know that, actually we've already done that. We know that we're dealing with this angle here, correct? We don't actually need to know that angle to answer this question. Now, if this were the only question we had and it said solve for theta, yes, we would need that. But we don't need to know that. We just need to know the tangent of that value of theta. And we can find that ratio without ever actually calculating theta. So tangent of this would be equal to opposite over adjacent. I'd like to do one more of those. Let's say cosine of the tangent, inverse tangent or arctan of, let's do 3/5. So I'm gonna erase these numbers. So same type problem, just a few different variations. So we're going to work on this piece first. So this is asking for the angle that has a tangent of 3 over 5. Remember, tangent is opposite over, that didn't work out, opposite over adjacent. We're going to use the Pythagorean theorem to figure out the hypotenuse. 3 squared plus 5 squared equals hypotenuse squared. So that's 9 plus 25 is equal to hypotenuse squared. So h is equal to the square root of 34. So we know we're dealing with this theta here, so we want the cosine of that theta. So cosine is equal to adjacent over hypotenuse. And there we go. We were able to find that without ever solving for theta itself.